In the last video, we have seen the different formulas of the trigonometric identities. In this, we are going to solve the different type of question, and we will see how to implement the different formulas and different methods to solve the question. According to me, I always try to solve the part of the question which are in sec, cosec and cot mostly, like this. In this, we will solve the left hand side. We will convert this sec minus 1 upon sec a plus 1 equals to 1 minus cos a upon 1 plus cos a. So let's see what is the formula of sec. Sec a equals to 1 upon cos a. So one upon cos a plus 1 whole upon 1 upon, sorry, it's not plus, it's minus 1 plus, and this will be written as it is. Now we will take the LCM, so it will become 1 minus cos a upon cos a whole upon 1 plus cos a upon cos a. So this can be written as 1 minus cos a upon cos a multiplied by cos a upon 1 plus cos a. It's a basic formula. If something is written like this, we can write it in this form: 1 upon 2 multiplied by 4 upon 3. That's what we have done here. So in this we can see numerator has a cos a and here denominator has a cos a, so they will be cancelled, and our equation will be equals to 1 minus cos a upon 1 plus cos a. So I think that's what we have to prove in our question. Hence proved. In this question you can see that here is the sin a square minus cos square a is equal to 2 sin square a minus 1. If we solve the LHS left hand side, which is here, you can see that sin is also present and cos too, but on the right hand side there is only a sin. So this gives an idea how to solve the question. We have to only convert this cos to the sin. So let's see the formula: sin square a plus cos square a equals to 1, and we have to convert the cos, so cos square a will be 1 minus sin square a. Let's implement this to our question. Sin square a minus 1 minus sin square a, which is equals to 2 sin square a minus 1. So when we open the bracket with multiplication of minus, it will become minus 1 plus minus minus plus sin square a, which is equals to 2 sin square a minus 1. So here our sign is in plus and this sign is in plus, so this will add up to make 2 sin square a, and this is minus 1, so minus 1, which is equals to 2 sin square a minus 1. To see how we can think first to solve from the question. You have seen many questions where you will find that here the terms are in addition or subtraction and the same terms are here in multiplication. So let's see how to solve this type of question. First of all, we will convert this tan to sine square upon cos square. Tan A is equal to sine A upon cos A. So here it's square, so it will become sine square A upon cos square A plus, sorry, it's minus here, minus sine square A upon 1. So if we have to take LCM, A upon B plus C upon D, it's very simple. B multiplies with C, D multiplies with A, and they multiplied with each other. It becomes A into D plus C into B upon BD. Something like that we will do in our question. Sine square A into 1 minus sine square A dot cos square A upon cos square A dot 1. So it will be equals to sine square A minus sine square A dot cos square A upon cos square A. Now you can see that we can take the sine square common, so 1 minus cos square A upon cos square A. One minus cos square A is equals to sine square A as per the formula. So we can write it as sine square A upon cos square A dot sine square A, and this sine square A upon cos square A will become tan square A. Tan square A dot sine square A. This is what we have to prove. Tan square A dot sine square A, and here in our numerator it is given that 1 minus sine A upon 1 plus sine A, which we have to prove equals to sec A minus tan A ka whole square. So in this we will rationalize the denominator. Let's see how to rationalize it. 1 plus sine A. We will multiply the numerator and denominator by the opposite sign of the denominator, which will be 1 minus sine A upon 1 minus sine A. If we multiply A plus B into A minus B, it becomes A square minus B square. So just like that, you can see here 1 plus sine A multiplies 1 minus sine A. So it will become 1 square minus sine a square, and it will become 1 minus sine a whole square. So it will become 1 minus sine a का whole square upon 1 minus sine square a. According to our formulas, if we see, sine square is equals to 1 minus cos square a. So 1 minus sine a whole square upon 1 minus cos square a. This will be equals to 1 minus sine a whole square upon 1 minus 1 plus cos square a. So we can write it as 1 minus sine a का whole square upon this plus 1 and minus 1 will be cancelled out and only cos square will be left. 1 minus sine a upon cos a whole square. Now we can see that here it is sec a and tan a. So we have to break a 1 upon cos a minus sin a upon cos a. So 1 upon cos a is equals to sec a, and sin a upon cos a is equals to tan a, and here it's whole square. So I think that's what we have to prove. Sec a minus tan a's whole square. In this question we can see that here it's sine to the power 4a minus cos to the power 4a, which is equals to 2 sine square a minus 1. Here we can see that we have to transform the power and disappear this cos. So let's see how to do it. We will apply this formula. A square minus b square is equals to a plus b into a minus b. So first of all we have to convert it into to the power 2. So we can write it as sine square a का whole square minus cos square a's whole square. So now we can see that it's in this form. So we can write it as sine square a plus cos square a into sine square a minus cos square a. So as we know, sine square plus cos square is equals to 1. Sine square a plus cos square a is equals to 1 from the formula. So it will become 1 into sine square a, and here cos is left and we have to convert it into sine. So it will become cos square is equals to 1 minus sine square a. So minus bracket 1 minus sine square a. So it will become square a minus 1, and this minus and minus will become plus sine square a. Here sine a and here sine a, they will add up to form 2 sine square a minus 1, and that's what we have to prove, equals to RHS 2 sine square a minus 1. I found this question difficult, so that's why I have picked this question up. Here it's given sine a plus cosec a whole square plus cos a plus sec a whole square, which we have to prove equal to 7 plus tan square a plus cot square a. Here our goal is to make this 7. So let's see how to do it. First of all, we will expand this square, so it will become sine square a plus cosec square a plus 2 sine a cosec a plus cos square a plus sec square a plus 2 cos a sec a. Earlier from the formula we have seen that cos a dot sec a is equals to 1 and sin a dot cosec a is also equals to 1. So here it's cos a sec a and sin a cosec a, so they will become 1. Sin square a plus cosec square a plus 2 multiplied by 1 equals to 2 plus cos square a plus sec square a plus 2 multiplied by 1 equals to 2, and they add up to form 4 sin square a plus cosec square a plus cos square a plus sec square a plus 4. And here you can see cos square a and sin square a, and they are in plus. So sin square a plus cos square a is equals to 1. So now we will have cosec square a plus sec square a plus 1 plus 4. So it will become cosec square a plus sec square a plus 5. And as we know, cosec square can be written as 1 plus cot square a. Cosec square a can be written as 1 plus cot square a, and sec square a can be written as 1 plus tan square a. So cosec will be changed into 1 plus cot square a and sec square will be changed into 1 plus tan square a plus 5. 5 plus 1 6 plus 1 7, and it will become cot square a plus tan square a plus 7. And I think that's what we have to prove in our question. Tan square a plus cot square a plus 7, cot square a plus tan square a plus 7. Okay. Here in our question, it's under root 1 plus sin a upon 1 minus sin a, which we have to prove equals to sec a plus tan a. When we see under root, what comes first into your mind? Of course, squaring both sides. But here we will not do that. If we square both sides, it will become a lengthy to solve. We will rationalize its denominator. 1 plus sin a upon 1 minus sin a multiply by 1 plus sin a upon 1 plus sin a. So it will become under root 1 plus sin a whole square, and as we know, a plus b into a minus b is equals to a square minus b square, and here a minus b into a plus b, so it will become a square minus b square, and cos square a is equals to 1 minus sin square a. So it will become under root 1 plus sin a whole square upon cos square a. As you can see that here it's square, so it will come out of the root and become 1 plus sin a, and here it's cos square and it will come out as cos a only. Now we will distribute the denominator. 1 plus cos a plus sin a upon cos a. So 1 plus cos a is sec a, and sin a upon cos a is tan a. See, in few steps we have done the question. Sec a plus tan a, which we have to prove, is equals to RHS. In this question, it is given that x cos a plus y sin a is equals to m, and x sin a minus y sin a equals to n, and we have to prove that x square plus y square is equals to m square plus n square. So we will put the values of the m square and n square. So it will become x cos a plus y sin a whole square plus x sin a y cos a whole square. When we open the whole square, it will become x square cos square a plus y square sin square a plus 2x cos a plus y sin a. And if we open this bracket, it will become plus x square sin square a minus y square plus y square cos square a minus 2x sin a minus y cos a. So from here we can see that x square cos a and y square cos a, so we will bring them together. It will become x square cos a plus y square cos a, and just like that y square sin square a x square sin square a plus x square sin square a plus y square sin square a. And here you can see that 2x cos a into y sin a, 2x cos a y sin a, here it is in plus and here minus, 2x sin a y cos a, it's in minus, so they will cancel out. So if we take common cos square from here, it will become x square plus y square cos square a plus sin square a x square plus y square. And now we will take x square plus y square common from both, so it will become x square plus y square is common and left will be sin square a plus cos square a, which is equals to 1, and we will left with only x square plus y square. That's what we have to prove in the question. Thank you very much for watching the video. For any query or ask me in the comment section.